viewers, welcome to this session on WebAssembly. So in this session, I'll talk about what is WebAssembly and what it brings onto the table as opposed to JavaScript. Later in the session, I will also show you how to install a toolkit, namely the Emscripten tool that you can use to develop WebAssembly applications in C and C++. There are many tools available for different languages, but I will be focusing on Emscripten later in the session. So let's get started. So WebAssembly is a technology that will be useful in the front end side of applications, in the web applications. We know that many applications are today targeted to the web. Even applications like video games are now targeted to the web than ever before. So web is in a very unprecedented state. That's undoubtedly the case today. And it's also not a surprise that if we learn that JavaScript has been the dominating front-end programming language up to now. That's what has been powering dynamic web applications. Of course, HTML, CSS and stuff were there on the front-end side, but what brought life to web front-end is JavaScript. So it's still the dominant language, but these web applications that we look at today are demanding much more than what JavaScript is really designed for. For example, these applications want faster load time, faster execution once the application runs on the browser. So these things are at a particular level is being achieved by JavaScript. So JavaScript has been doing a great job, but it's still not enough. So application developers are pushing those applications to the browser and demanding more and more performance, and JavaScript has its own limits to do that. So these requirements led browser vendors to come up with innovative solutions. So the first such solution brought to the landscape of technology was the Asim.js from Mozilla. So Mozilla came up with an idea to write some part of those front-end code in C and C++. We know C and C++ are native languages which you can compile to machine code which will run very close to your hardware, which itself is less costly and brings performance improvements and stuff like that, right? So this Asim.js technology used a transpiler to convert C and C++ code to JavaScript, so which is what ends up as Asim.js. So you write code in C and C++ and then transpile it to Asim.js. But Asim.js, what benefit it brings and what innovation Mozilla brought in was in that Asim.js, they had some special hints for JavaScript engine, which is on your browser, JavaScript virtual machine, to avoid certain monitoring it usually does. For example, JavaScript, as you know, is a interpreted language. It's a scripting language, and it's very dynamic, and it doesn't have strong data types. Like a particular variable can hold a string, and then it can the same variable can hold an int, float, and so forth, right? So JavaScript engine needs to keep monitoring those variables to make sure that it does its job right. But so this is a costly operation. Keeping an eye on all those variables is a daunting task. If we can avoid that, at least in certain cases, you can achieve some level of performance improvement, and that's exactly what Asim.js is doing. Asim.js has special hints to the JavaScript engine to tell JavaScript engine that you don't need to keep monitoring these variables and so forth. But it has its own drawbacks as well. Anything is like that. So WebAssembly included, right? So Asim.js, what drawbacks it had was basically it still ends up transpiling the C and C++ to JavaScript. So it's nothing different. What runs on the browser still thinks it's JavaScript. So you are running JavaScript. So is it a real drawback? I'm not sure, but it's considering the benefits that we need to look into, that may sound like a drawback. Yeah. So, but the other thing is JavaScript itself was unwittingly made a compiler target, which it is not designed for. For example, you write C++ and you transpile a code to JavaScript. So there are many other technologies doing the same. So, but the main problem is that you are supposed to write JavaScript, but you are now generating a code to JavaScript. So that means from another language, you are sort of compiling that to JavaScript. So which means you are making it a compiler target. So right, originally JavaScript was not designed for that, right? So that means you cannot make use of some special uh, optimizations and whatnot, those kind of things that you usually do in compiler targets, that you can't do anymore in this kind of method. So, and also the innovation that you need to do in asm.js technology, that when you write code in languages like C, C++ and convert to JavaScript, means you still have to do a lot of changes to JavaScript language itself, because it was not designed for this. So when someone comes up with an idea like this, there might be certain changes that you need to do to JavaScript specification itself, which is what has happened for asm.js. But when it comes to changing the original JavaScript language, it's not an easy path. So, but that means it hinders the growth of this kind of technology, and you cannot make the maximum use of what you came to know about, what you can do in these kind of technologies. And and of course, the resultant JavaScript file, as I said, it ends up being a JavaScript. So what actually the browser downloads from the web server is still a JavaScript file, which is asm.js, which can become considerably larger, which means you still have to transport that over the wire, and that can take time. So the load time is still not improved when it comes to asm.js. So this is what actually led to WebAssembly. So WebAssembly was born because of all these drawbacks of asm.js. So browser vendors really like the idea of asm.js, but they were experimenting, researching about how they can mitigate those shortcomings. That's when major vendors like Google, Microsoft, Apple, and Mozilla, so all these big companies have their own browsers. Google has Chrome, Microsoft has Edge and Internet Explorer, Apple has Safari, and Mozilla, of course, has Firefox. They agreed and designed a common low-level assembly-like binary language, which is ideal for a compiler target. So what they thought was, why do we need to compile or transpile another language into JavaScript? Why not we convert or compile that into a common language, just like what we do in a conventional programming language to execute. We target that to run in a browser. So we have to make a language, or a machine code or a bytecode like language that browsers can understand. So once we design that and all the browser vendors agree, you can bring up a specification saying, okay, you can have your browser understand this new language, so which is a WebAssembly. So that's exactly what happened. So this is what became known as WebAssembly. So they agreed on a common language format, assembly language, low-level binary format, that browser engines, browser virtual machines, or JavaScript virtual machine to be correct, to understand this language. So that came about the WebAssembly. So initially, so tools, you need tools to do that, right? So we need to understand we need tools to do that. So if you write a code in a particular language and you want to make sure that language is converted to this binary like assembly language, you need a tool to do that. So the first few programming languages to add support for such a thing was C, C++, right? So those languages had something, and then Rust followed up, and they caught up with some other toolkit, and they had certain tools to do the same. And those tools were really ideal because ultimately what you are compiling is sort of a bytecode which these languages can easily do, right? So many of the programming languages are now adopting WebAssembly. So we hope there'll be more and more support on WebAssembly technology with other languages as well. According to my research, I found a few tools for Go, TypeScript, and C Sharp. They are either in a very matured state or still under development. I haven't done my research on that, but I recommend you to do your own research if you're one of those developers. So, but in this session, I'll be covering a tool called Emscripten, which is a compiler that you can use for C and C++. So what does WebAssembly solve? Why do we need? So I told one reason earlier that many web applications are now demanding high speed, high performance applications to the browser. So JavaScript has its own limitations or its own uh, limits to achieve that level. It has been doing a great job up to now. But still, as I said, faster loading, that means from your web server, wherever that you're hosting your web application, to a consumer or client's browser, you still have to download all those code and all those machine code that you have or instructions that you have, whatever that is, like your programming code of JavaScript or compile code of some form, needs to first come to the browser and then execute, right? So that bit of files needs to be as small as possible, and that's when even in a very slow internet connection you can download those things faster. So that's one area that WebAssembly solves, because WebAssembly is ultimately a binary, so it's a compact form. So it uh, it achieves faster loading and of course faster execution, because it is written in a strongly typed language and you compile it. So the compiler knows beforehand some of those types that you have for those variables and whatnot, and that allows it to add optimizations targeted for various hardware architectures. So that's definitely one of the goals. So that's what Asim.js also did with hints, if you remember what I told earlier, right? So yeah, so that's the another advantage, the faster execution. And of course, WebAssembly technology brings those two advantages along with the ability for you to use other languages in the front end world. Of course, up to now JavaScript was ruling and kind of it was all over in the front end, but it's changing. So that's good for all, right? So that means you can use your existing libraries in those other languages, and you can use your expertise of those languages to bring in some innovative web applications to the web. So yeah, so next thing, let's discuss how JavaScript works. So this is important for you to have a good understanding of what WebAssembly brings and what JavaScript has been doing up to now. And so you have a JavaScript file in your web server along with, of course, your HTML and CSS files and whatnot. So when you load that web page in your browser, there is a JavaScript virtual machine, JavaScript engine. So you download that file. So that file will be downloaded, by the browser. And JavaScript file, as I said, JavaScript is an interpreted language. So most of the time, the JavaScript virtual machine interprets, which means when it's run, it goes through the code and understands what needs to be done and executes that. So that's what an interpreted language does. So every time when it needs to be run, it will be read. But later on in the JavaScript world, they understood that they can be doing these things if they want performance. So they wanted some sort of a compilation to be done to the machine code, so that no need of certain monitoring as such. So they came up with this idea called just-in-time compilation. So what it does is, like, once a code has been run enough time, JavaScript engine will understand about the nuances of that code, and it will understand, okay, this variable never becomes a string. It looks like it's only an int. type of knowledge. It gains that, and once it gains that, then the JavaScript engine compiles that piece of code to the machine code, so that it doesn't need to monitor that bit of code anymore. So that is JIT compilation, but still that has other drawbacks. JavaScript engine, even though it gives us that monitoring, it still keeps uh, a little bit of an eye on that code, like just in case if that variable uh, gets a string or whatnot, those kind of things. So if that happens, it has to scrap it off and then bring it back to the interpreted stage, and you have to go through that cycle again. So that's what JIT compilation brought. So it solved the problem to a certain extent, but not fully. So that's exactly what is happening in the JavaScript engine. Next, let's see how a WebAssembly works. So WebAssembly, as I said, you write your code in C, C++, Rust, or any other supported language. So you still have to compile that to a binary, which we call the WebAssembly binary or a WASM file. So this WASM file is what you download to the browser, and it runs within the JavaScript virtual machine. So note that, right? It still runs within the JavaScript virtual machine, which means browser's JavaScript engine is not going anywhere. It's still called the JavaScript virtual machine, so that you are not replacing JavaScript with WebAssembly. JavaScript is still there, right? And so this WebAssembly is code is anyway developed in a strongly typed language. That means the web developer already knew the types of those variables and whatnot. So JavaScript virtual machine can freely assume that this WebAssembly code knows everything beforehand, right? So it compiles freely without any doubt to the machine code at that stage, and that machine code will never be looked at in terms of monitoring as such, right? So it will be kind of executed just freely as a normal native code that you execute in your machine, but inside the JavaScript virtual machine. That's exactly what's happening, and that's how the faster execution is achieved. And of course, faster loading time is achieved because this WASM file, compared to some of those JavaScript or even asm.js, is comparatively low in size. So that means the loading is quite faster. So that's how the WebAssembly works. So some important things to remember is that WebAssembly technology is evolving, and it's not uh, fully matured as such, but so that also means WebAssembly is not intended to replace JavaScript. JavaScript is an awesome language, and you have plenty of frameworks, libraries, and whatnot in JavaScript already. So to completely get rid of that, it's going to take years of effort. So the best is not to kind of target to replace it, but to complement it. So WebAssembly technology can complement the JavaScript technology. So whenever you have a demanding application that demands faster loading, very faster execution that JavaScript cannot achieve, that's when you have to target whether you can implement that bit of code, the WebAssembly. And yeah, so the WebAssembly technology is designed in such a way that it can be used outside the browsers as well. For example, it doesn't have to be run inside a browser. Now we know technologies such as Node.js exists, where JavaScript is now brought to the backend side as well, because Node.js was developed using Chrome's V8 JavaScript engine, and it's been pulled out and then made to run separately, right? So that brought in capabilities to use JavaScript in the backend. So you can target your WebAssembly to run on Node.js as well. So that means it's outside the web browser. And there can be other types of platforms emerge as well, because there is a standard being formalized called WebAssembly Standard Interface. So if a platform just adheres to this interface, a WebAssembly code will be able to run on that platform. So there'll be more platforms coming up for sure, and only time will answer whether that kind of platforms will emerge or not. So if that happens, you can write WebAssembly, you can write your code in C, C++, Rust, or any other supported language, and then compile it to WASM and run it on that platform that supports this WebAssembly standard interface. And so I mentioned that WebAssembly is a binary, but it was designed in such a way that it also has a text counterpart, which means it's not fully like a native binary code that you never ever see a text format, uh, except of course your high level programming language that you have written. So but this text format is again something browsers can use for debugging, and you can also as a developer use it for debugging and so forth. So we'll see some of these things in a later session, so when we come to that. So next is about Emscripten. Let's see how to install it. Okay, so Emscripten is a toolkit that you can use to compile C and C++ code to the Wasm binary. So what you finally get when you compile C++ code using Emscripten is a file called .wasm. It's a binary code that's what you will put in your web server, and that's what get downloaded into the browser. So underneath, the Emscripten tool uses an LLVM compiler. So in Mac or Linux, or even in Windows, it uses the CLang compiler or Clang compiler to compile that human readable language that you write into an intermediate representation, which we call an IR. So that part is what you call the compiler front end. So that compiler front end, CLang, will convert it to an intermediate language. Then the compiler backend, that's when Emscripten chip in, and then it compiles that intermediate representation into a machine dependent bytecode. That WASM file is finally an x86 architecture dependent, or x64 architecture dependent or whatnot, that kind of thing. So it depends on or ARM architecture dependent. So it depends on the architecture end of the day. So let's see how to install the Emscripten toolkit. So these are few, so I just jotted that down in the presentation itself so that you can have that as a reference later on. So msdk is the command that you need to finally initiate when you run. So but let's run these things and see if Emscripten is already installed or not. So msdk list will make sure that it's already installed or not. If it's already installed, you can update it right away with msdk update. Otherwise, we'll have to issue these commands after downloading the msdk or Emscripten tool from the GitHub repository. Okay, so yeah, so before that, yeah, so let's see msdk list. I don't have it anywhere. So anyway, so even after I download it, there is a particular way of doing it. So I'll make sure that how to do that. So let's see how to download the Emscripten tool. So if you go to this GitHub repository, that's Emscripten SDK, you have to either clone it or download it. I already have got that downloaded, right? So let me go to my programs. I have WebAssembly. So as you can see, I got this msdk main 6. So that's what you get when you download that, right? So first let me unzip it. So that should do it. So you have that msdk main, so go into that. Right, so you have to run this particular tool and use your install latest. So by the way, before I go into that, sometimes before you install this, make sure that you also have Python in your machine. So that will be important for you to later test your WebAssembly code, because Python brings in a capability to run a local web server. But if you have a separate web server and you are intending to do testing in that web server, you don't need to have Python, but just in case so in my case, I already have Python installed, so I don't need to worry about it. So it's already there, and you can run a Python web server as well. And Emscripten tool has a way of running that Python web server intrinsically as well. So that's why I mentioned that you better have Python installed. But if not, you can have MSDK install latest. So once you do this thing, okay, it says right, there is a problem. Let's see what the problem is. Okay, so now you see there's a problem. So it says error downloading URL, and it's trying to download Node.js. So as you can see, Node.js, and there is this URL open is a Python thing, and it says certificate fail, unable to get global issuer certificate. So this seems to be an SSL issue, weird issue. So but we want Python, we don't want Python to have this kind of problem, but we just need the Emscripten to be installed. Let's install it, let's see what is there. So if I just issue Python thing, so it's Python 397. I'm not sure what are the Python versions I have. I do have Python 3.7 as well. Maybe I can try running with Python 3.7 just to make sure that it's not a problem with Python 3.9. If not, I will have to resort to Python 2. I do also have Python 2 installed. So in fact, this MSDK is a script. So what it's actually running is MSDK Py. So I can maybe use Python 3.7, but let me try this first. I should get the same error. sdk.py install latest. Expectedly so, yes. So let's try 3.7. Oh, it seems like it's going this time, so that's great news. So this should take a while. This should take about maybe, depending on your internet speed, this should take about a couple of minutes. So let's come back once this is finished. Okay, so now it looks like Emscripten is installed with Python 3.7, of course, but it downloads the Python 3.9. It downloads to Node.js and a few other tools that's necessary. So this is all you have got to install Emscripten. So of course, once it is installed, we can run these commands to activate it and then also start using it simply. Yeah, so let's look at that, and then so we just have to do this. Maybe we can this time try without Python script. MSDK activate the latest. This should activate the MSDK. Yeah, all good with that, and then obviously we can start running this source MSDK env. So if you look at this, you find MSDK env for different shells, batch scripts, C shells, and so forth. So I'm gonna source it MSDK env shell. This should do the job. Now if I just use MSDK without the dot slash, I can do that, but without the dot slash, even if I do that, in fact I need that. Yeah, MSDK is there. MSDK list. This should show a bunch of details about the version that you have downloaded and other Python dependencies and Node.js dependencies and so forth. So that says the story. So if you want to update, you can update. I think because we have just installed it, it would have taken the most latest version because we installed the latest version. So that's all we have got in terms of installing Emscripten. But there are other tools as well. If you look at this particular GitHub repository. It says the WebAssembly binary toolkit. So this is useful to convert the WebAssembly binary to the text format and text format to the binary format. So this GitHub explains, for example, as you can see here, WebAssembly text format to binary format and so forth. Those tools are there, but you have to build this thing from the source code. I'm not gonna show you that, so because this GitHub repository has all the instructions to do that. You just have to clone it using Git, and then you have to download, initialize the submodules, and then build it using make and cmake, for example, right? So you need to have C development tools installed, the CMake like tools installed, and the C compiler, C or C++ compiler installed as well. So with that, our installation of the tools are complete. And yeah, so last thing that I just wanted to quickly show you is this. I got this file, the HTML file called WebAssembly support check. So I'll just open it up for you to see what is in there. And this file you can use to open up in a browser and check if browser supports uh, WebAssembly or not. So simply, as you can see, this is just nothing more than a JavaScript. So JavaScript objects, you can check for the WebAssembly object. So basically this console log calls this function is WebAssembly supported. If it returns true, it will state in the console that WebAssembly is supported. Otherwise it will say WebAssembly is not supported. So if you look at what happens inside, in a try catch block, the object WebAssembly is checked against, and if that is there, and if it's an object, if that object exists, basically you go through here and you create this WebAssembly module with this magic number. So this is nothing more than /0 WASM, so in fact ASM, and then the version number 100 is what you have done here, and taken the module. If that module is an instance of WebAssembly module, you just return that instance, otherwise it will throw an error. So that's what is happening here. And we can maybe start in a browser and see what happens. So for that I need to open up my file directory. So and then let's see it in the browser. My directory where I had my msdk zip file and the extracted directory where we installed the Emscripten. So this is the file that you got. So let me open up in the Firefox browser to see how things look like there. And as you can see, the browser is supported or not. We can see in the console, and it says WebAssembly supported. So then you're all good with that. Yeah, so let's open up in the Chrome and see what does it say. Yeah, should take a while to open up. Okay, there you go. So yeah, so if I just go here, console, it also says WebAssembly is supported. Likewise, you can open up that particular file in any other browser. Maybe we can also quickly check in the Edge, Microsoft Edge, or in Safari. Maybe let's open up it in Safari and see if it's supported or not. In Safari also we can view the source view. So we have to first enable the source view in the preferences. So you can go there, and in the advanced menu you have to enable show develop menu in the bar, and this should bring the develop menu here, and you should be able to see the source view from right clicking as well. So if you just go to that and then go to console, you see the WebAssembly is supported. So that's WebAssembly supported in Safari as well. So now let's quickly have a look at it in the Edge browser. So let me, yeah, you can just quickly open in the Edge and right click, inspect, and in the console WebAssembly is supported, right? Okay, pretty much that's all I wanted to cover for today. So I'll meet you in another session, maybe on implementing a real WebAssembly code for a web application. I'll see you then. Take care. Thank you for watching. Subscribe to my channel, please.